Hi guys. Today we're going to be going over 2.2, which is the characteristics of quadratic functions. A couple things before we start. I do want to let you guys know that this is a normal, just like a normal class period. I know you guys are watching a video, so it's a little bit different. However, you still have homework over the material that we cover today in this video, and it will be due tomorrow. So the nice thing about watching the video is that you can pause it whenever you want and take as long as you need to write down some of the things that we're going to have on the slides. So just make sure you're taking advantage of that, and let's go ahead and get started. So our objectives for this section are to explore properties of parabolas, also find maximum and minimum values of quadratic functions. We're going to graph quadratic functions using x-intercepts, and we'll solve real-life problems. We won't finish 2.2 today, so we probably won't get to all these objectives, but that's okay. So the first thing that I want to talk about is the axis of symmetry, and that is a line that divides the parabola into mirror images and passes through the vertex. So I'll kind of highlight the axis of symmetry here. Because the vertex of the quadratic function f of x is equal to a times x minus h squared plus k, since the vertex of that is hk, the axis of symmetry is a vertical line at x is equal to h. So a vertical line is always represented by x equals wherever my vertical line is. And my vertical line that I'm going to draw is going to pass through my vertex. So all I need to do is let x equal whatever my h value is right here. Okay. And we'll talk about that more in detail here in a second. So there are some steps to graphing quadratic functions using symmetry. The first thing we're going to do is identify and plot our vertex. The second thing we'll do is find the axis of symmetry at x equals h. Number 3, we're going to choose two x values to the right of the vertex. The fourth step is we're going to use substitution, which means that we're going to plug in our chosen x values for x into our function and determine what our y values are. And then the last step, we're going to reflect over the axis of symmetry. So the axis of symmetry is a key part to graphing these quadratic functions using symmetry. And what it actually does is kind of cut our work in half. So we drew all those tables before, and now we're just going to get pretty much straight to the graphing. So let's look at the first example. It wants us to graph this function and label the vertex and the axis of symmetry. So the first thing I want to do, I'm going to follow the steps just like in the previous slide. And the nice thing about the video is that you can go back to that slide if you need to. So my first step is to identify and plot the vertex. Well, we talked about this yesterday, and our vertex is hk. Which means pulling from this quadratic, my vertex is -3, +4. If you cannot remember how to get the vertex from a quadratic function, then go back in your notes, ask your neighbor, whatever you need to do, because that's a pretty important step. You need to know where your vertex is. So I have my vertex. The second step is I need to find my axis of symmetry. Oh, and I just realized something. In the first step, I should have plotted it. plotted the vertex. So let's go ahead and do that. I'm going to kind of backtrack on you guys, sorry. So it's -3 and up 4. There it is. So now I need to plot my axis of symmetry, which we were told that its x is equal to h, and h is -3. So my axis of symmetry is x is equal to -3. It's really important that I say the axis of symmetry is x is equal to -3 and not just -3, because the axis of symmetry is a line. And if I say that the axis of symmetry is -3, well, I don't know. That doesn't tell me. That's just a point. That's not a line. So how I'm going to represent it is actually a dotted line in a different color. In the textbook, they use a just a regular straight line, but I'm not going to use that in this example. So then our third step is to choose 2 x values to the right of the vertex. So this is my x values. And to the right of the vertex, that would give me x is equal to -2 and x is equal to -1. I would choose the points that are really close to the vertex. I mean, to the right of the vertex is kind of arbitrary, but I wouldn't choose like +7, because that's going to be, your graph is probably going to go off of your graph, if that makes sense. So we chose our x value, so the fourth step is to substitute to find our y values. So we're going to take our original function and plug in -2. So my original function is -2 times x, which I'm going to plug in -2 first. And then copy down the rest of the function. I'm just doing substitution, that's it. So evaluate inside the parentheses, I'm left with -2 times 1 squared plus 4, which is equal to 2. So then let's do x is equal to 1. I have -2. And then putting -1 in for x, plus 3 squared plus 4. I'm just copying down the rest of the function, just like I did previously. So -1 plus 3 inside the parentheses is +2, and that's squared, plus 4. Which is -2 times 4. 2 to the second power is 4. So I get -8 plus 4. I'm running out of room. Which is equal to -4. So my 2 points from here are -2 and 2 and -1, -4. That's from that second one. Okay. So let's go ahead and plot those points. I have -2, 2, which is right here. Then I also have -1, -4. 1, 2, 3, 4 down. let me extend my axis of symmetry line. So now I did step 1 through 4, so now I need to do step 5, which is reflect. And that's reflecting over the axis of symmetry. So watch how I do this. So for the vertex, it's already on the axis of symmetry, so I don't need to worry about that. But for that first point, I'm going to kind of write this in purple. I am one x value, or one space, away from the axis of symmetry. So I'm going to travel a distance of 1 unit to find my reflected point. Same idea here. There's a distance of 2 between the axis of symmetry and my point. So from the axis of symmetry, I'm going to go a distance of 2. And that's my reflected point. You don't need those purple lines there. I just did that to show how I found my reflected points. And you could probably see that without drawing those lines. So I'll just go ahead and erase them so we can just see the graph. So we graphed, we labeled the vertex, which was that first step, and we found our axis of symmetry. And I'm just going to box those things. All right. Awesome. So the second example, we want to graph the function and label the vertex and the axis of symmetry. So very similar process. So the first thing that I want to do is identify my vertex. So step 1, my vertex is -1, 0. That's my vertex. Second step is I want to, and again, let's make sure that we graph the vertex first. So the reason why I don't have an XY table on this graph is because this graph, it actually goes outside of the parameters of the normal graphs that we use. So I'm going to go ahead and create my own XY table. So I'm going to put my y-axis, or my x-axis, I'm sorry, right here. So this is my x-axis. And then I am going to put my y-axis here in the middle. So this is like a normal graph, but now I kind of shifted it down. And the reason why I'm doing this is because this graph would be hard to see if I don't do that. So again, the vertex is -1, 0, which is right here. So the second step was the axis of symmetry. And we take our h value, and that's equal to x. So x is equal to -1. And that's our axis of symmetry. Abbreviate there. So again, I think I'll go ahead and do it in red. And it's always going to be a vertical line when we're dealing with quadratic functions. And that is a line at x is equal to -1. So then we have the third step, which is choose 2 x values. So my two x values to the right of -1, I'm just going to do the closest one, which are x is equal to 0 and x is equal to +1. So the fourth step, I'm going to substitute into my original function. So my original function is -3 times x plus 1 quantity squared. So for x is equal to 0, I'm going to plug in 0 in for x. So I have -3, 0 plus 1. This is all multiplied by the -3 squared. And when I evaluate that, I get -3 times 1 squared, which is just -3. So my first coordinate point, I take my x value, then I take my y value that I found, and that's my coordinate point. So this is for x is equal to -1. I have -3, and I'm substituting 1 in for x, plus 1 squared, and if I evaluate that, it's -3, 2 inside the parentheses, and that 2 is squared. So I get -3 times 4, which is -12. And so my coordinate point, I'm taking my x value, which is actually right here, that 1. So my ordered pair is 1, -12. So let's go ahead and graph those. So I have 0, -3, which is right here. I know my y-axis is a little squiggly. And then I have 1, -12. So this is why I shifted the graph down, like the window of the graph, because we go down -12. So we have -3, -4, -5, 6, 7. Oops. Oops, I lost count. It's actually the last one. So that works out. And of course, it's not wanting to plot my point. There it is. Okay, so I have 2 points to the right. Then my last step is to reflect over the axis of symmetry. So very similarly to what I did before, let's take that point at the bottom. Well, it's 2 away from the axis of symmetry, so I need to go 2 units left of the axis of symmetry. And then let's look at that point up here. 0, -3 is 1 unit away from the axis of symmetry. So my new point, my new reflected point is right there. And then I just need to draw my lines to connect my graph. So yeah, I know that this drawing isn't picture perfect, but you guys get the idea. So I have my vertex, I have my axis of symmetry, and I have my graph. So we're done with this. Go ahead and try this example on your own. Pause the video and take as much time as you need. And then once you think you have an answer, go ahead and play the video and I'll go over the answer. Okay, so same procedure. that we're using, the first thing that we want to do is, let's use a different color. My vertex is at 2, 5. So let's go ahead and plot that. So again, this graph kind of goes off the normal parameters of the graphs that we have. So I'm going to kind of shift the graph up this time, and I am going to let this bottom line here be my x-axis. And then I'll still keep my y-axis fairly close to the middle. Trying to make this line as straight as I possibly can. This is my y-axis. That's my x. Okay, so my point is positive 2, and then up 5. 1, 2, 3, 4, 5. There's my point. And the axis of symmetry, remember, is a line, and its x is equal to my h value, which is 2. So it's always going to pass through that vertex. There we go. So then my next step is to choose 2 x values to the right of my vertex. So I would use x is equal to 3 and x is equal to 4. Do my substitution step, which is step 4. So plugging into my original function, I have 2 times x. I'm going to put 3. I'm doing x is equal to 3 for this one. Minus 2 squared plus 5, which is equal to 2 times 1 squared plus 5, which is equal to 7. So my coordinate point is 3, 7. And this whole thing was for x is equal to 3. So for this one, I'm going to substitute x is equal to 4 into my function. So I get 2 all times 4 minus 2 squared plus 5, which is 2 times 2 squared plus 5, which is equal to 2, and I need to evaluate that squared term. 2 times 4 plus 5, and that is equal to 8 plus 5 is 13. So my coordinate point, I'm going to write that in red, is my x value was 4, and my y value 13. So I'm going to go ahead and plot those points. So positive 3, 7. So this is right here. Then I also have 4, 13. So 7, 8, 9, 10, 11, 12, 13. Ends up being on the top. Oops. Getting a little crazy with my pen. Okay, so there are my points on the right, and then I need to do my reflection step. So I have a point right there, and right there. Graph looks much better than the ones I've done in the previous slide. Oh yeah, and I didn't write this down, but remember our last step is to reflect, which is what I just did about the axis of symmetry. So now real quick, let's talk about minimum and maximum values. So for a quadratic function, the y-coordinate of the vertex is the minimum value. So that is when a is greater than 0, and my maximum value when a is less than 0. So again, to recap, I actually had to pause that recording in the middle. Actually, let's look at, first of all, ignore this part right here. Don't worry about that for now. So we're just focusing on the minimum values and the maximum values. So the y-coordinate of the vertex is the minimum value when a is greater than 0, and the maximum value when a is less than 0. So don't let that confuse you. When you see the graph, it's going to be pretty straightforward. So I'm going to draw my xy plane. So when a is greater than 0, I will have a graph that looks like this. And the reason why it'll be upward shaping is a negative a means that I have some sort of reflection going on. So I'm going to go over again the standard form of a parabola, or the vertex form of a parabola. So if I have a positive a out here, I'm going to have a upward shaping parabola. And this will be my vertex, which, looking at your y values, this is the lowest point in the graph, this point right here, this HK. So does it make sense that our minimum, in this case, is just whatever K is? That's our minimum. So then let's look at when A is less than 0, which means that A is negative. I'll have a parabola that is facing downwards. The vertex isn't necessarily going to be on the y-axis, but the only thing that A tells us is which direction the parabola is facing, up or down. So if A is negative, so if we have, it would look something like this. We have y is equal to negative a, x minus h squared plus k. And like I said, we'd have a downward facing parabola. This point right here is the highest point in our graph. So this would actually be a maximum. And we just look at our y value. And then this, again, is hk for our vertex at k. So if we have an upward shaping parabola, our k is our minimum value. And if we have a downward shaping parabola, our maximum is at k. Either way, we're looking at k, but what we're trying to determine is if it is a minimum or a maximum, and that all just determines on which direction the parabola is facing. So real quick, let's do some examples. My vertex here is 2, 4. So let's graph my vertex. 2, 1, 2, 3, 4. I see that I have a negative a value. So my parabola is going to do something like this. Probably not as wide. But I really don't care. If it's just asking me to find the minimum or the maximum, I don't care what my parabola looks like. I know that it's going to be downward facing. So this is my HK, or my vertex is 2, 4. So since this is the highest point in my graph, I have a maximum at 4. Now, we can't say a maximum at y equals 4 because y equals 4 is actually a line. And in this case, we are just looking at a point. So saying that the maximum is 4 is an okay answer. Let's look at this graph on the right, graph B. We have a vertex at negative 3, positive 1. So negative 3 up 1. I see that my A is positive, so I know that my graph is going to do something like this. It doesn't need to be an exact drawing if they're just asking for the maximum or minimum. And since my A is positive, I know that my vertex is the lowest point on my graph, which means I have a minimum at my y value, which is 1. So that's it for the video. You guys are going to have a few minutes left to start working on the assignment. Rewatch anything that you need that you weren't really clear on. You can ask us questions over the homework tomorrow. And thanks for listening. See you tomorrow.